Once upon a time, Antarctica was not the icy, barren land we know today. It was a fertile expanse teeming with life, a haven of rich soils and abundant ecosystems. Yet over millions of years, it transformed into the frozen desert we now associate with the southern pole. How did this monumental transformation occur? What forces shaped this continent into its current state of icy isolation? The answers to these questions take us back to the late Paleozoic era, about 600 million years ago. At that time, all the continents on Earth were united in a supercontinent called Pangaea. Antarctica, far from being an icy wasteland, was part of a lush and temperate region. But the Earth was on the brink of a significant change. Slowly, Pangaea began to break apart, setting the stage for Antarctica's dramatic transformation. The breakup of Pangaea marked the beginning of a chain reaction that would eventually lead to Antarctica's icy future. As the continents drifted apart, the climate and ocean currents of the planet underwent radical changes. About 180 million years ago, Antarctica began to separate from Africa and South America. This separation created new oceans and altered global atmospheric conditions, setting the stage for a gradual cooling of the continent. In its earlier days, Antarctica was closer to the equator and enjoyed a much milder climate. As millions of years passed, it drifted southward, inching closer to the pole. This journey brought cooler conditions and paved the way for glaciation. However, this was no overnight transformation. The cooling process was slow, spanning millions of years and involving a series of geological and climatic shifts. During this time, the shifting continents disrupted global ocean currents, causing temperatures to drop significantly. Antarctica, now isolated in the southernmost reaches of the Earth, began its transformation into a land of ice. About 34 million years ago, the transformation accelerated. A significant drop in atmospheric carbon dioxide levels triggered a global cooling event. The Antarctic circumpolar current began to form, isolating the continent and cutting it off from the warmer waters of other oceans. This isolation was a turning point. It marked the beginning of the Ice Age in Antarctica. Massive ice sheets began to form, covering the continent in layers of glacial ice. These ice sheets preserved the history of the Earth within their frozen depths, each layer a time capsule of ancient climates and atmospheric conditions. Antarctica's icy transformation had far-reaching effects. The cooling of the southern pole influenced global climate patterns, bringing significant changes to ecosystems and weather systems across the planet. Today, Antarctica is not just a land of ice. It is a vault of Earth's history, holding secrets from millions of years ago. The ice layers contain trapped air bubbles, fossilized remnants, and ancient sediments that offer insights into past climates and life forms. Beneath its massive ice sheets lie vast subglacial lakes and hidden ecosystems. These underground environments remain some of the least explored regions on the planet. Scientists believe they may harbor ancient forms of life that evolved in isolation for millions of years. Could these hidden worlds hold clues to the origins of life on Earth? As researchers drill into the ice and explore these subglacial environments, they uncover data that could revolutionize our understanding of Earth's history and its future. The mysteries beneath Antarctica's ice are a reminder of how much we have yet to discover. Today, Antarctica's future is deeply intertwined with global climate change. The rapid melting of its ice sheets poses a significant threat to global sea levels, with the potential to reshape coastlines and displace millions of people. Scientists are closely monitoring the continent, studying its glaciers and ice flows to predict the impacts of global warming. The data collected from Antarctica is vital for understanding how the planet is changing and how we can prepare for the challenges ahead. But Antarctica's importance extends beyond its ice. The ecosystems beneath its frozen surface, the untapped resources in its depths, and the secrets preserved within its glaciers make it a key player in humanity's quest for knowledge. As we continue to study this frozen continent, Antarctica will remain a source of wonder, a place of profound mystery, and a symbol of the Earth's resilience and fragility.